Let's answer quiz 2, number 3. The horizontal force P is applied to the handle of the puller. Determine the resulting tension in the chain in terms of P. Answer will be an equation in terms of P and T. So first, to solve this problem, syempre, free body diagram. So what is your body? Ano yung body mo sa problem na to? Syempre, yung puller. Ito yung puller. And then, ito yung body niya. It is anchored sa point A with a hinge connection. And then, nakatali siya dito. So since chain itong nandoon sa point B, since chain yung nasa point B, ang reaction na mabibigay lang niya ay tension. And then sa point A, since hinge connection siya, it can provide a horizontal and vertical reaction. And our applied force is CP. Itong CP, no? So we want the system to be in equilibrium. So let's draw the free body diagram. That means lahat ng pwedeng i-express as forces, express na as force. Alisin na natin yung mga connection. And then ang matitira lang is yung body and yung mga forces. Wala na yung drawing ng connection. So we have point B and point A. So kay point A nga, meron tayong vertical and horizontal reaction. So call AY and AX. Yan ang assumption ng direction nila. And then dito sa point B, may chain ka. So that will be in tension sa point B. So since this is point B, ito yung force due to that chain. Let's call that tension force. And then nasaan si applied load natin? Nandito sa ito. This is our applied. And ang distance niya is from point B, given ang distance niya as 720 mm. And then, hindi given ang distance ng point A to point B. I mean, hindi given yung distance na ito, no? Hindi given yung distance na yan. Ang given is itong 180 dito. 180. And then, ang given instead also is the 40 degree and ito na 20 degree. So, for this one to be in equilibrium, dapat lahat ng mga reaction forces natin and yung applied forces should be equal to 0 kapag ginamit natin yung tatlong equations of equilibrium. So what are the equations of equilibrium? Summation of moment equal to 0, summation of forces y 0, summation of forces x 0. So those are the applied and reaction forces. So umpisa tayo sa summation ng moment doon sa point A since dalawa ang reaction missing doon. So moment tayo at A equal to 0. Ano ang applied force? It's P. So, what's the distance of P dun sa point na A? Wala pa. So, we need to get this missing distance. Para ito ang missing natin. Pag ginad doon, yun na yung distance ni point A to our force P. Yun ang kanyang moment arm kasi. So, let's find X. So, let's call that X. So, to find X, we can use this angle for P degrees. And itong distance na 180 degrees. Using sa katoba, X is the opposite side. So we can use sine 40 degrees equals to opposite X over hypotenuse 180. So X is 180 times sine 40 degrees equal to 115.7 mm. So now we know yung moment arm ni P. Let's write. And then, anong direction niya? It's counterclockwise. About A kasi, no? So, it's counterclockwise. So, it's positive. P times, what's the distance? 720 plus 115.7 mm. Next force, it's T. So, yung T, Nano? So, si T, inclined siya. No, inclined siya, hindi given ang perpendicular distance niya. Kasi from point A, ang perpendicular distance kasi niya should be this one. It's not 180, it's this line. So, imbis na kunin mo na lang yan, mas madaling tingnan, gagamitin ko itong, yung X, and itong distance na to. Let me call this Y na lang. So, Y. Bakit? Kasi i-component ko si T, Tx, and then this is Ty. I-component ko na lang si T. Then, gagamitin ko si distance X and itong distance Y. So, let me just erase muna that. So, let me find Ty using yung 180 mm and 40 degrees ulit. And so, katawa. So, ano na to? This is cosine, no? Since y is the adjacent side, so cosine 40 is equal to y over 180. Our y is equal to 180 times cosine 40 equal to 137. Hindi. 888. Ay, ayaw. 137,888 mm. So, yun ang moment arm na gagamitin natin. So, component na siya, no? So, TX muna. TX muna ang gamitin natin. TX, ano ang kanyang direction ng rotation? Ito ang point A. So, ganyan, clockwise siya. Negative TX times, ano moment arm? It is X. That is 115.7 mm. Then, let's check TY. Kapag hihila to, pag ganyan din siya, so negative TY din, times, ano ang kanyang moment arm? It's Y. And Y is equal to 137.888 mm. So, wala na, no? That's all yung mga forces and reactions. So, equal to 0 na tayo. So, kung titingnan, ang equation, tatlo ang variables natin. It's P, Tx, and Ty. And sabi nga dito, answers will be in terms of P and T. So, let's express this Tx and Ty in terms of T. Tx is equal to, ano ba? Cosine of T is cosine theta. And then Ty is sine T sine theta. But what is this theta? So, kung titingnan mo to, given ng 20, no? Let's move here. Medyo magulo na yung figure. If this is 20, this is also 20 since baliktaran angle. So, to get this Tx, we can say Tx is equal to T cosine 20. And Ty is equal to T sine 20. So, substitute natin siya dito sa equation. So, let's call na this. This is 20. This is also 20. Substitute natin siya dun sa equation. So, P is, what is 720 plus 115? 115.7. 0.7 minus Tx is T cosine 20 times 115.7 minus T sine 20 times 137.888 equals 0. So, let's simplify. This is a numerical coefficient, numerical coefficient. So, let's simplify the equation. 115.7 times cosine 20. This is 108.722t and 137.38 times what? Sine 20. That's 47.16t equals 0. So, we can combine yung t. And parehas sila ng sign, so additive. So, pag add natin yung 108.722 plus 4716. How much? Negative 155.882 t equals 0. So, isolate natin si t. Ito yung answer sa book eh. So, isolate natin si t. We should have the same equation. Substitute as the transpose. It is 155.882 t equals 835.7t. Isolate t. So, divide mo to. 155.882. So, t is equal to 835.7 divided by 155.82. So, it's 5.36p. Is it the same? Ayan. So, the same na. Let's answer now number 4. The self-regulating floodgate ABC pinned at P. Ito si B. Ay, wala. Ito. Ano ba? Ito ang B. So, let's answer number 4. The self-regulating floodgate ABC pinned at P, and this is point B. So, pin connection dun. So, pin connection, vertical and horizontal reactions. So, pin at B and is pressed against the lip of the spillway at C. So, may press na action dun sa pin C. Ibig sabihin, that's the normal force. Since naka-ano lang daw to, parang nakapatong lang siya, di ba? Parang naka-press lang siya sa lip ng spillway. So, nakapatong lang siya. So normal force lang nangyayari dun. So, spillway at C by the action of the 3645 Newton weight at A. So, since may weight dito, so, kumbaga, itong weight na to, pinupush downward, kaya napupush pa po ganun itong gate na to. So, nasasara niya ang gate, nakasara ang gate, kahit may tubig dito, hindi po pour out ang tubig palabas kasi may weight ka dito, may pabigat ka. So, napupwersa itong gate na sumara. So, if the gate is to open, when the water level reaches more than the height na 6 meters, so sabi niya, the gate will open kapag ang height ng tubig dito ay 6 meters pataas. So, above 6 meters, mag-o-open na to. So, what does that mean kapag mag-o-open na to? Ibig sabihin, yung pabigat na to is not enough para i-close niya ito. Ibig sabihin, wala na rin yung normal force dito. Kasi, mag-o-open na yung gate, ibig sabihin, wala nang touching surface dito. So, walang touching surface, that means there's no normal force na. Kasi, mag-o-open na nga yung gate eh. Pero as long as below 6 meters pa, okay pa yung pabigat, pinupush niya yung gate papunta sa point C. So, may touching pa, may touching surface. So, may normal force pa doon. But remember, kapag mag-open na siya, hindi na kaya ng pabigat. So, there's no more touching. Mag-open na yung gate kapag above 6 meters na yung height ng water. So, for that, determine the distance x locating the weight A. So, what is the perfect distance or the distance para ganun ang maging mechanism ng gate na to? The distance at x where the floodgate will open kapag 6 meters na itong water dito sa right side. So, this means the system will be in equilibrium when water is 6 meter height. More than 6 meters, mag-open siya. So, yun nga, sabi natin. So, ibig sabihin, wala ka ng normal force dito. So, ano na lang yung force mo? Itong pabigat and itong water na to. Kung saan this is from the bottom, this is 6 meters from the bottom. Given ang pressure niya, so, titingnan nyo to, ang magnitude ng pressure is 320 times H. So, ibig sabihin, yung H is yung 6 meters kasi yun yung design height natin. So, it will be 320 times 6. How much is that? 320 times 6, 1920. So, our W is equal to 1920 Newton per meter. Okay? So, wag mong gagawin na 320 Newton per meter times H na 6 meters tapos ika-cancel mo tong Newton ay yung meter, edi naging 1920 Newton yan. Hindi na yan W, hindi yan distributed load. That is a force na lang. Force na lang yung water, which is mali. Dapat distributed load pa rin siya kung saan Newton per meter or force per linear unit ang unit ng W mo. Hindi mo ika-cancel si meters. Imo-multiply mo lang si 6 dun sa 320. So, you get the magnitude of your distributed load. So, nakuha na natin yung distributed load. Okay. Pag 6 meters, ano ba? Hindi natubura. So, kapag 6 meters, ang W natin is 1920 Newton per meter. That's our W. And then, if this is 6 meters, and this is 6 meters, 3 meters, hindi nagsulat. This is 3 meters. So, this is, how much? 3 meters din to. And then, yung extra ito is 3 meters din kasi 6 ito. Okay, so huwag kayong papalito. Ibig sabihin lang, hindi nakascale yung drawing. But this is 3 meters din. 3 meters to, 3 meters to, 3 meters to. Okay? So, let's now solve. Let's draw the free body diagram. So, what is our body dito? We have yung gate. Ganito ang shape ng gate. Nakapin siya dito sa B. Sabihin mo may vertical and horizontal reaction. You can name them Bx and By. So, our weight is at point A, and it is how much? 3645 Newton. And then, dito sa point C, meron bang nangyayari? Wala. Wala kang normal force. Pero yung load mo is a triangular load and it is distributed over the length ng gate simula sa dito papuntang point C. This is W 1920 Newton per meter and this is your triangular distributed load. And then ang distance nito ay wait lang. So this is 3 meters. This is also 3 meters. So ito yung free body diagram and this distance is what we want, Cx. So we want this to be in equilibrium. So anong gagawin natin? Moment. Usually, sabi nga natin, we usually start yung pag-solve ng problem sa moment, no? Pati dun sa pagkuha ng reaction, nagmo-moment tayo dun sa may mga unknowns na mas madami. So, dito, nasan yung point kung saan nandun yung unknowns, diba, kay point B. So, summation tayo ng moment sa B. Sabi ko, block A. So, ano ang applied force? Let's say W. And then, another force, 3645 Newton. So, unahin natin si W. Since distributed load ito, kailangan mo munang kunin yung kanyang resultant. And ang pagkuha ng resultant ng distributed load is like getting the area ng iyong load. So, this is a triangular load. So, get the area ng triangle na yan. So, triangle is base times height over 2. So, for this one, what is our base? So, ito yung base. Sabihin natin yan, 3 meters. What is our height? Ito yung height natin. It's your W. So, W is 1920 Newton per meter. So, let's get the resultant of this triangular load. It's 1920 times 3. Let me show you the units. Newton per meter times 3 meters. So, nag-cancel na siya. So, since triangle divided by 2. So, this is equal to 1920 times 3 divided by 2, 2880. 2880 Newton. This is the resultant ng triangular load. And nasaan ang pwesto ng triangular load? Diba? Dun sa centroid ng triangle. So, centroid ng triangle natin is 1/3 from the height niyang to. And that is dito, this is 1 meter. So, the remaining ng triangle is 2 meters. Okay? So, what is the distance na natin from this centroid point ng triangular load to point B? So, it is a total of 2 meters plus 3 meters. So, that's 5 meters. Yun ang ating moment arm ng R or resultant ng triangular force natin. So, let's draw na ang R natin. So, nandito siya. This is the resultant ng triangular load. Okay? And then, 5 meters is the distance ng triangular load to point B. O, hindi na. Okay. So, ayan. This is R and this is 5. So, okay na. Pwede tayo mag-summation ng moment. Ulitin natin. Lipat ko lang to. Summation tayo ng moment sa B. So, umpisahan na natin sa load ng water, which is R. So, R, about point B, clockwise siya. So, it's negative. Negative R is 2880 Newton times ano ang moment arm? It's 5 meters. Next, ano ang 3645? Pag iikot siya about B, it's counterclockwise. So, it's positive 3645. Ano ang moment arm niya? That is our missing X. May ibang force pa ba? Wala na. So, makikita nyo, X is the only missing. So, isolate natin siya. So, we can solve for it. So, lipat natin to sa kabila. 3645, X is equal to, magiging positive na to. So, 2880 times 5. So, divide mo to para isolated ang X. X is equal to 2880 times 5 divided by 3645. So, X natin is 3.95 meters. Is it the same? Ay. Wala tayong answer. What happened? So, nakuha na natin yung W. Now, ito ba yung gagamitin nating W? itong buo. Syempre, dapat hindi itong buo ang gamitin nating W. Kasi, itong pressure na to is for the pressure dito sa concrete pedestal na to. So, ito lahat tatama sa concrete. So, ang tatama lang sa gate is starting doon sa 3 meters na to. So, itong triangle lang na to ang involved sa floodgate. So, kapag ngayon, i-drawing na natin yung free body diagram, etong triangle sa floodgate na 3 meters lang ang included. Hindi yung buong triangle, hindi kasali itong nasa bottom. So, let's now draw the free body diagram. So, ganito ang shape ng floodgate natin, angled. So, meron tayong point B. So, point B ay hinge support. So, let's say meron kang vertical, horizontal na reactions dyan. Assume yun yung directions. Next, meron kang weight at point A. So, weight, ganyan ang representation natin. The weight is 3645 newtons. Ang distance niya from point B is X, which is our missing. Ang gusto natin kunin. So, next, yung load natin. Dito, yung triangular load. So, it only acts 3 meters from point C. Ito ang point C natin. So, nandito yung triangle. So, ito yung ating triangular load. So, anong W ang gagamitin natin? So, WC ang ating gamitin. So, ano tong WC na to? Ito yung WC dito, di ba? So, how do we get yung value ng WC? By ratio and proportion. So, meron tayong big triangle, meron tayong small triangle. Big triangle is, yung base niya si W, and then, that is for the height na 6 meters. And then, proportion siya dun sa small triangle, kung saan ang base ng small triangle is WC, and kung saan ang height niya is 3 meters. So, let's get WC. It will be 3W divided by 6. So, W is 1920. So, our WC is 3 times 1920 divided by 6. 960 Newton per meter ang WC natin. So, WC like 960. Okay? So, ano pa yung mga forces? Since we are designing for equilibrium, so, yun yung point kung saan, and sabi ng problem, gusto niya yung X value kung saan nasa verge of opening na yung gate, which is at 6 meters na. So, ibig sabihin, wala na nga tayong, hindi. So, ibig sabihin, wala na tayong NC dito. Walang NC dito. Ibig sabihin, wala na ibang force. It's only WC and 3645 Newton na pabigat yung weight. Yan lang yung forces natin. Now, since we want equilibrium, pwede natin gamitin na yung 3 equations of equilibrium. So, they are summation of forces sa Y equals 0, summation of forces X 0, and summation of moment equals 0. So, usually, nag-start naman tayo sa summation of moment kasi usually dun tayo nakakakuha ng answers and we evaluate dun sa point kung saan may maka-cancel out na mga variables. So, ano ba yung point kung saan may variable? It's point B. So, let's do summation of forces at point B. So, anyway, missing natin is X, no? Ito yung hinahanap natin. And we already have WC. It's 960 Newton per meter. Now, we can solve. So, umpisahan natin summation of moment natin sa triangular distributed load. Suruan ko lang to. Now, let's start. So, since distributed load ang WC, system of forces pa yan, i-represent natin siya. Kunin muna natin yung resultant force niya. So, resultant ng triangular load is like pagkuha ng area ng shape or ng load mo. Since triangle to, we use the area ng triangles. So, that is base times height divided by 2. Yan ang area ng triangle. So, this is the resultant ng distributed triangular load na WC na yan. So, what will be your base? It will be, diba, this is 3 meters. As we know naman dito. Ito, kung saan na-distribute yung triangular load, it's 3 meters. So, that's 3 meters yung base mo. So, what is your height? It is, ito, yung height, yung peak ng triangle mo. It's WC. Which is equal to 960 Newton per meter. So, let's now get the resultant. Resultant is yung area ng triangle na base times height, wherein base is 3 meters, times height, which is WC na 960 Newton per meter. So, makikita nyo, magka-cancel na yung meter. So, our R is equal to 3 times 960 divided by 2. Laging namamatay. 1440 Newton. Newton na lang natira. So, saan nilalagay si R? Yung resultant na yan. Diba ang centroid ng triangle is 1/3 from the peak ng triangle. Ito. So, that is ito. This is 1/3 of 3 meters. So, that is 1 meter. So, meaning the rest of the triangle is 2 meters. And then, how much is this? Diba that's 3 meters? Ito. So, that is 3 meters. So, what is now location ng ating resultant? Nasa centroid ng ating resultant, R, and it is 3 plus 2, 5 meters from point B. So, kapag mag-summation na tayo ng moment at B, yun ang magagamit natin dito? Moment arm ng WC. So, summation tayo ng moment at B, umpisahan natin sa WC. So, this is your point B. Pag mag-a-act ng resultant ng WC, so, clockwise ang kanyang direction. So, it's negative 960 Newton per meter. Ay, si R na palang gagamitin ko. So, R is 1440 Newton times ang distance niya. Moment arm is 5 meters. Okay na, force and distance na. So, that's moment. Next is 3645. Pag umikot yan sa point B, it's counterclockwise. So, it is positive 3645 Newton. Moment arm niya is yung missing natin na X. So, wala nang ibang force. So, equal to 0. We need to find X. So, let's isolate X. Lipat natin to sa kabila. So, 3645 Newton. X is equal to 1440 times 5. Okay, wala na. So, naging positive na to since nag-transpose tayo. So, divide mo yan. So, divide both side 3645, 3645. Our X is equal to 1440 times 5 divided by 3645. It is 1.975 meters. Is it the same? So, the same. 1.975 meters. Dapat ito ang X natin. So, our X should be so our X should be 1.975 meters para kahit 6 meters hindi siya sasara, pero paglampas ng 6 meters bubukas na ang gate, rotate na siya dahil mas malakas na yung pressure ng tubig dito kapag mas mataas sa 6 meters ang tubig. So, number 5, the machine operator produces the tension T in the control rod by applying force P to the foot pedal. So, there's a rod dito. So, this is a machine. Ito yung foot pedal part. Ito yung foot pedal part. Ngayon, kapag nag-push doon sa pedal, syempre may matatension ito dahil, kumbaga, merong rod dito, nakakonect siya. So, pag pinul to, aangat ito, matatension itong material natin dito. Okay, so the question, determine the largest P, the magnitude of the pin reaction at B, ito yung B, is limited to 1.8 kilonewton. Neglect the mass of the mechanism. So, anong ibig sabihin nun? Since meron kang yung foot pedal mo at point A, kapag nag-push ka ng P, matatension nga to kasi aangat ito. Kasi may pin ka dito. So, kapag pin, may vertical and horizontal reactions ka. So, magro-rotate siya sa B, aangat itong point C. Matatension itong rod na to. Kaya meron kang force T, which means tension doon. Ngayon, hindi given ang P, hindi given ang T. Okay? Pero ang isang given is yung reaction at B, which is 1.8 kilonewton. So, ang reaction sa B, supposedly dalawa, vertical and horizontal, di ba? BY and say BX. Dalawa yung reaction dyan. Pero bakit isa lang ang given? Kasi, ang ginawa lang dyan, ni-resultant itong BX and BY. Kaya, ito yung 1.8. Ngayon, may isang kulang pa dyan, which is yung angle ng 1.8 from the horizontal. Yun ang isa pang missing. So, wala tayong P, wala tayong T, wala tayong theta. But we have 3 equations of equilibrium, kaya this can be solved. Ngayon, you don't need yung BY, you don't need your BX, kasi ito na siya, si 1.8 na siya. Naka-resultant lang. So, you can just use 1.8, kaso wala kang theta. So, ito yung binigay kong hint. Point B is a pin support which has 2 reactions. But the given reaction at point B is just 1.8. So, ayun nga, gaya ng sabi ko, naka-resultant lang yung Bx and By into si 1.8 kilonewton. So, ang wala mo lang is the direction of the resultant 1.8, si theta. So, 3 missing, T, T, and theta. But this is solvable since we have 3 equations of equilibrium. So, now, saan magandang mag-start? Sabi natin, usually magandang mag-start, mag-moment. So, saan ka mag-moment? Doon sa may makakancel kang unknown. So, sa point B ba, mag-moment? Parang hindi, kasi nandun yung given mo. Kung mag-moment ka sa point B, hindi mo magagamit yung given. So, as much as possible, dapat yung equations mo involve yung given. So, huwag kang mag-moment sa B. So, saan tayo mag-moment na maganda? It's either sa C or sa P. So, ano ang tinatanong nga ba? Ang tinatanong is the largest P. Yung P ang tinatanong na. So, saan ka pwedeng mag-moment? Kung saan magiging involve ang P at ang resultant 1.8. Hindi kay C. So, try natin mag-moment at point C. Summation of moments sa point C equal to 0. Umpisahan natin sa applied load na P. So, P, ang pivot point natin is C. Kung mag-a-act si P, ang direction ng rotation niya is counterclockwise. So, it is positive. So, that force is P times ano kanyang moment arm, it is 150 plus 50. Ito, 150 plus 50. So, next force is yung resultant, 1.8. So, I think mas better na i-component natin siya. Kaysa kunin natin ang moment arm kasi na 1.8. If 1.8 ang gagamitin, ito Ito yung moment arm. So, I don't wanna bother solving for that moment arm. Mas gusto kong i-component ko siya into B, Y, and Bx. So, kung magka-component ako, isa lang naman din yung i-consider ko. Since Bx, this one, will pass kay point C, hindi ko na siya i-consider sa moment. Kasi magpapass siya sa mismong C. Ang magkakos lang ng moment is By. So, mas madali. So, kung mag-a-act si By, ano ang direction ng force, ay ng rotation niya? It is clockwise. So, it is negative. Negative By. Ano ang kanyang moment arm? It is 50. Okay, 50. So, By. May iba pang force? Wala na. But By is unknown, so express natin siya in something na known siya. That is si 1.8. So, 1.8, no? So, By, ano yan pare? So, By is equal to 1.8 kilonewton sin theta. So, wala tayong theta. So, kung this is my equation 1, this is my equation 2, I will substitute 2 in equation 1. So, that will be 200 P minus 1.8 sin theta times 50 equals 0. Let me call this equation 3. I need some more equation para makuha. Dahil dalawa pa yung unknown ko. So, ano tayo? Summation of forces along x nga. So, ano yung mga along the x-axis? It is t and dx. So, t is going to the left, right. So, positive t. And then, cosine 25 dahil horizontal component lang. We assume bx to be going to the right, no? Let me change na going to the left siya. Kasi, para ma-maintain equilibrium, dapat magkahiwal, sila. So, that is bx. Wala na, no? So, bx is equal to 1.8 cosine theta. So, let me substitute bx. Ba't nasulat ko by? So, substitute ko ito dito. Huh? So, that will be t cosine 25 minus 1.8 cosine theta equals 0. Okay. So, how many unknowns? Let's call this equation 4. Okay. 2 unknowns pa din ako dito. Nadagdag si t. I need one more equation. Summation of y naman. Summation of y, ano ang mga may y? Of course, it's t, dy, and vertical component ng t. Going down si p, so negative p. Going down si t, sine 25 going up si by. And remember, by is ito din. So, substitute natin. Plus, what is by? Ito siya. It is 1.8. Hindi ko na muna ilalagay yung equation 5. So, ayun no, tatlo ang unknowns natin. So, magsa-simultaneous equation tayo using equations 3, 4, and 5. So, gagamitin natin yung tatlong equations na 3, 4, and 5. So, for equation 3, simplify muna natin siya. It is 200 p minus 1.8 times 50. So, 19. Negative 90 sine theta equals 0. Next equation, equation 4. It is t cosine 25 minus 1.8 cosine theta equals 0. Then equation 5, negative p, negative t sine 25 plus 1.8 sine theta. So, anong maganda para ma-solve tong equation na to? So, let's simplify this muna. Isolate ko si P. Isolate natin si P. So, it will be P equals 90 sine theta over 200. Equation 1 muna. Then, let's isolate T dito. Cosine theta over cosine 25. Equation 2. Tama ba? 1.8 cosine theta, cosine 25. Okay na. So, simplify natin further into numerical. Itong 90 P is equal to 90 divided by 200 is 0.45 sine theta. And then 1.8 divided by cosine 25. This is T equals 1.986 cosine theta. Okay. So, ito na yung simplified na equation. Ngayon, itong dalawa, i-substitute natin kay equation 3 na to. Okay, let's do that. So, our P is negative 0.45 sine theta minus our T is 1.986 cosine theta. And then sine, hindi nagsulat, 25 plus 1.8 sine theta. So, ang ating variable is only theta. Let's further simplify. And then, gamitin natin yung solver ng calculator. So, simplify natin to. So, this is negative 0.45 sine theta minus 1.986 times sine 25. This is 0.839 3 cosine theta plus 1.8 sine theta. So actually, we can combine ito and ito. No? Oh. Transpose natin. Okay. Divide natin ito sa cosine theta. This will become 1.35 tangent theta. And this is Cancel, 0.8393. And then isolate natin si tangent theta. And then arctangent natin to. Theta is equal to 31.869 degrees. So let's find P. Ano nga ba? 31.869. How much is this?
Check the classes. No, the another one. Taas. Oh, magbaba? Even baba again. Baba?
So, nakuha naman natin. Ito, kilonewton, 0.23759. Kilonewton. That is same sa dito. Kaya nga.
Hindi, Daddy. Look at that. Yung mga on this option, yung mga candy. Diba, zero candy.
So, ito yung answer natin. So, what we got, so naka-express lang tayo sa kilonewton. So, if you convert this into newton, it will be times 1,000 newton. So, that is our P. So, nakuha naman natin. No? So, kahit hindi tayo nag-calculator, hindi tayo nag-shift solve or simultaneous equations, nakuha pa rin natin siya using algebra.